Hi everybody and welcome to today's class. Today we're going to be talking about wildfire, specifically the causes, consequences and future of wildfire. Now, this is kind of an interesting topic because about 14 months ago, so a year and a couple of months, this was one of the biggest topics in the world, ecologically and socially and everything. Everyone was going crazy about the wildfires in Australia and the wildfires in California. And then the pandemic came along and kind of swept it all under the carpet. But let's not forget, this is still a huge deal. So today we're going to be talking about the history of it, what's happening with it now, and what's likely to happen in the future. Okay, so I'm just going to share my screen. Let's see, let's find, once again I've got far too many windows open, so here we are. Okay, so by the end of this class, you guys should be able to describe the causes and consequences of wildfire and compare and contrast the future of wildfire. Well, before we start, it's probably worth going through, well, what is wildfire? So it's defined as a sweeping and destructive conflagration, especially in a wilderness or rural area. So not any fire outside or in the woods is a wildfire. It has to be sweeping and destructive. Okay, it can't just be an isolated little incident. Some of these are pretty big. So this is a NASA image of Australian wildfires in January of 2020. And this is what large parts of California looked like in 2019 and 2020, unfortunately, and will likely occur again this year. Now, wildfire, generally the amount of wildfire is driven by two different components. One is the number of fires, so how many fires are occurring, and that's determined by the ignition sources. And the second component is the burn severity and burn area, and that's determined by environmental conditions. The number of fires can also be determined a little bit by environmental conditions, but one of the biggest components of it is the ignition sources. How many are getting started? So let's talk about the ignition for the causes of wildfire. Now, what's critical to remember all the way through this lecture and all the way through any discussion about wildfires is that natural fires are a feature of many ecosystems. Not all ecosystems, and there are nowadays some ecosystems that are experiencing wildfire that really should not. For example, the tropical rainforest in the Amazon is now experiencing wildfires, which it really shouldn't at all. It's never experienced them in the past. But in many ecosystems, natural fires are a feature. Naturally, these fires are usually started by lightning. So you get lightning strikes, that can start large fires. What we call dry thunderstorms are common here in the West. You've probably experienced them a few times since you've been in Logan. It's where you get these big lightning strikes, loads of thunder, but you don't get any rain. So they're called dry thunderstorms. And you can imagine that's pretty bad for wildfire. They tend to occur in the summer when it's driest, and then you get a big lightning strike, and of course there's no rain, and so you get a big fire. Now, many systems actually require some wildfire in order to maintain diversity. So, do you remember from quite a few classes back, we talked about the intermediate disturbance hypothesis. Some disturbance can be good, too much can be bad, but some systems are fire evolved, and the whole community is actually more diverse when you have a certain amount of wildfire. However, when it comes to ignition, currently 85% of USA wildfires are human caused. The vast majority are from, most human caused fires are from unattended campfires. This just shows an image of somebody who returned to their briefly unattended campfire when they went to the bathroom and came back to find that the campfire had spread, set alight the whole wood and started to climb the trees. So unattended campfires account for the majority of all wildfires in the US. There is the rule of too hot to touch is too hot to leave. So before you leave your campfire, you should be able to put your hand into the fire. If you can't, you should not be leaving that fire. I live just down the road from Green Canyon, Every single year, there's mini fires get started up because so many people go camping in Green Canyon and they just abandon their fires. So it's pretty bad because I live about a mile away from it. In addition to unattended campfires, we also get the abandoned cigarette situation. People throw cigarettes out of moving cars, landed in grass, that can spark a wildfire. Also, there are lots of cases of deliberate arson. This fella had recently gone through some troubles in his life. He went to high school in California. He was living in Missouri. He made the decision of, I'm going to drive back to my high school reunion, which was taking place in California. Because he'd had a rough time of things, he decided the world deserved to have a rough time of things too. And the whole way through his journey, he was setting fire to little pieces of tissue paper and just throwing it out the window. And he set off 13 wildfires in California. The world record is by this guy who managed 141 wildfires in Colorado. So people do actually go out and just set things ablaze. So it does happen. In addition, there are lots of ways that your vehicle can start a fire. So if you've got an off-highway vehicle, they can generate exhaust spark. So off-highway vehicles and dirt bikes must be equipped with spark arresters on the back of them. In addition, tyre pressure. So underinflated tyres may compress. That causes the road to make contact with the wheel itself, and that can throw out sparks. Hot engines on your off-highway vehicles. So it says never park or drive over dry vegetation. So hot components can actually ignite grasses and brush. In your truck, things like catalytic converters and other exhaust components can ignite fuels they come into contact with. They can also fail and propel white-hot pieces of metal over the terrain, which is not good. Dragging chains, they can cause sparks. And even your brakes. Severely worn brake pads can start throwing red-hot bits of metal about the place, which can set off wildfires. So there's a whole bunch of ways in which your vehicle can start a wildfire. So that's the causes of ignition. Now if we look at causes of wildfire and specifically the burn severity and area. So there's a couple of things we need to take into account. One is the moisture index of the landscape. The reason this is important is because fire burns hotter and more readily and moves faster in drier areas. This dryness is affected by species composition, rainfall and temperature. In addition to the moisture index, we have the fuel load. So higher fuel load, more fuel, means fire burns hotter and longer. And this is affected by species composition and the age structure of species. So if you think about it, these sort of dry grasslands will have a very different moisture index to the wet rainforest of the Pacific Northwest. When it comes to fuel loads, huge stands of old and mature trees will have a very different fuel load to an area that's just got short grasses on it. And so these two components form an awful lot of how big of an area will be burned and how severely that area will be burned. Okay, let's just do a quick clicker question, make sure we're paying attention. So what percentage of USA wildfires are human caused? So A, 30%, B, 50%, C, 10%, D, 85%, or E, 95%. Just give you 10 seconds on this. Okay, well the answer is D. 85% of wildfires in the US are human caused, which is just crazy. So let's have a quick talk about effects of wildfire on the landscape. Well, we can start with the question, well, if wildfires are sometimes important to maintain biodiversity, why are they such a problem now? Well, the big issue is that wildfires are happening more often and they're burning a larger area than previously. So between 1995 and 2015, so the number of acres burned increased by 180,000 extra acres per year for that 30-year period. And if we look at this graph, remember how we read graphs? First of all, we look at what type of graph it is. Well, we've got scatter plot and lines, so scatter plot and line graph. Look at our axes. On the x-axis we have year, starting from 1985, 2015. On the y-axis we have areas or acres burned, and we can see we're going from about 200,000 in the 80s to over, well, about 1 million in the late 2010s. We have this continuous upward trend suggesting more acres are being burned, and fires are happening more often. Now remember the disturbance hypothesis, intermediate disturbance hypothesis. The intermediate disturbance hypothesis says that some disturbance is good, and many of these ecosystems are evolved to have an aspect of wildfire taking place within them. Some disturbance is good. If we have no disturbance, only the strongest competitors persist. Little bit of fire, it increases our diversity because now we have tolerant and competitive species coexist. But remember, on the intermediate disturbance hypothesis, too much disturbance is very bad indeed. So although a bit is good, too much is very bad. And our activities that we're doing as people contribute to massive changes in the moisture index. Now this figure here is a little bit difficult to interpret, so I'm just going to go through it slowly. On the x-axis we have time, going from January 2000 to January 2020. And on the y-axis we have the percentage difference of the moisture index from what we'd normally expect. And this is for the state of Utah. So D0 means that it's abnormally dry. So short-term dryness showing planting, growth of crops, some lingering water deficits, pastures or crops not fully recovered. We go all the way to D4, exceptional drought. So that's exceptional, widespread drought, crop pasture losses, shortage of water, creating water emergencies. This is what's happened over basically the last 20 years. So the only time when we're not at least abnormally dry, so different from what we'd expect, is in these white areas. And what the increase here shows is it shows how much of the state, what percentage of the state is affected or in these different categories. And what we can see is that there have been times, such as look at sort of July 2003, July 2004, when the entire state was in at least extreme drought, and about 20% of the state was in exceptional drought. We're up here. We're currently got an awful lot of the state in a severe drought, and most of it is in some sort of abnormally dry state. So our moisture index is showing that a lot of Utah periodically is considerably drier than we would expect it to be. And also climate change itself is increasing these wildfires, because increased temperature directly increases drying of fuel. So higher temperatures associated with climate change the moisture index by drying fuel out. And this drier fuel is also much more likely to ignite. So this, for example, is average minimum temperature versus year for 1990 to 2018 and in California. And you can see that within California, we've experienced these massive increases in wildfires. Between 1900 and 2020, so 120 years, we've seen the average minimum temperature increase by about 4 degrees, which is huge. And this increase in temperature not only changes the dryness, but it also causes earlier snowmelt and earlier runoff. Because remember, here in the Intermountain West especially, and in California, it is a snow-dominated landscape. So most of the precipitation falls in the winter as snow. It sits up in the mountains and then it runs down during the course of the year. So increased temperature makes that snow melt earlier and it causes an earlier runoff. And what that earlier runoff means is that the land is drier for longer. And this leads to an increase in fire season length. So if we look at, here is the years 1906 to 2016, and here we've got April to July runoff, and as a percentage of total annual runoff, and we see that this is declining because more of the runoff is occurring earlier. We're having an earlier start date to when the snow is melting and it's running off the land. Okay. And the effects of climate change have been really dramatic in Australia. So we may think of the California wildfires as bad. Well, they were and they are. There's no two ways about it. But Australia in 2020 was far, far worse. So the continent is literally burning, and it's starting again now. So this is that NASA image of Australia from space. And you can see pretty much the entire east coast, all the way down from Melbourne up to far north Queensland, and the Cape is almost entirely ablaze. This large section of Western Australia is ablaze. The reason this bit isn't ablaze is because it's one massive gigantic desert. There's no vegetation. Same for here. But even in Tasmania, which is the same climate essentially as Vancouver, Canada, it's ablaze. Now this, when you can see this sort of image, it looks, well, it's pretty shocking to begin with, but you can't really get an idea of scale. Well, here it is. So this is an area comparing Australia to California. So this area, just the east coast. So this was the area of 2009 Australia East Coast bushfires. This is them comparing to how big the bushfires were for all of California for all of 2019. So it's about 100 times bigger is the size of the wildfire just on the east coast of Australia. That's ignoring all of Western Australia and Northern Australia. So it was a huge deal. Now, the arid lands of Australia are a fire-dominated landscape. So historically, even going back, we can look at this through sort of prehistoric times, the arid landscape of Australia is dominated by fire. It's a very fire-dominated place. It's so fire-dominated, the major tree species, eucalyptus, are adapted to cope with fire. So eucalypts are very, very good indeed at surviving fire. They do very well in a fire-dominated landscape. However, the changing climate has altered the amount of fire. Although this group of trees is very good at dealing with fire, they've altered the amount of it. Because Australia is warming faster than the global average. So on this figure here, we've got time on the x-axis, we've got amount of degrees change, and the grey is the rest of the world, and the red is Australia. So you see, Australia is warming faster than the rest of the world. And this increased temperature in Australia has caused many issues, coral bleaching and all that sort of stuff, but we'll just talk about this one right now. And one of the big ones is that drought has affected the terrestrial and riverine ecosystems of Australia and also substantially increased the wildfire season. Okay, so it's another quick clicker question. So what best describes the current wildfire in Australia? A, there are no wildfires in Australia. B, wildfires are a natural feature of Australia and everything is normal. C, wildfires are a natural feature of Australia, but their intensity is now well above natural. Or D, Satan loves watching Australia burn. Just give you 10 seconds on this. Okay, well, the correct answer on this one is C. Wildfires are a natural feature of Australia, but their intensity is well above what they are naturally. But it's critical to remember that changing the climate is not the only way humans have affected fire regimes. There are many other mechanisms as well. One of the big ones has been invasive species, and invasive species have changed the fuel load on the landscape. One of the big ones here in the Intermountain West is cheatgrass. So cheatgrass arrived in the USA in 1961. It spread across the entire country by 1928. And it outcompetes native species, especially in grazed ecosystems. But critically, it is incredibly flammable. So cheatgrass grows very rapidly and it grows very tall. And then when it gets in the wet, and then when it gets dry, the grass just totally dries out, and you get these landscapes dominated by what literally looks like kindling. I mean, you could not design a better fire starter if you tried. This stuff is almost, it's just fantastic at having fire spread very, very rapidly because it's at much higher fuel load than native grasses, and it gets much drier than native grasses. And that leads to cheatgrass being twice as likely to ignite than other grasses. And because it grows so rapidly, it means we get shorter intervals between fires. And the quote about cheatgrass is, cheatgrass turns fires into infernos. So you can see this picture here from just around the Colorado area, this massive, gigantic fire on the mountains being driven by cheatgrasses. If you look at the spread of cheatgrass, so this is what annual grasses, all annual grasses looked like in 1990. By 2018, all this red is new invasive cheatgrass that's taken over an invaded sagebrush steppe. So we've had this switch from a very sagebrush dominated system to one that's very dominated by cheatgrass. But it's not the only invasive that's caused fire-related problems. So those old eucalyptus trees that burn very well in Australia, they are highly fire tolerant. They are actually, the species itself uses fire to outcompete other species because the bark of these eucalypts is designed to burn very fast and very hot. So it creates these very rapid, enormous amounts of fire, but the bark then doesn't burn for very long, and so it keeps the heat away from the body of the tree. And as a result, they survive the fire, but they generate these very hot fires, so it kills other trees. In addition, the species produces eucalyptus oils, and these can promote fire because they're flammable. These oils actually vaporize when they get hot, and so oils in the air then actually cause the air itself to burn. So it means that they facilitate the spreading of fire very quickly because their burning releases these oils into the air, and those oils allow the air to burn, and it means fire can spread between trees very quickly. So eucalypts burn very, very well indeed. And eucalypts were introduced to California in the 1840s. Now eucalypts, when they got to California, they grow very well in nutrient-rich Californian soils. So I'd seen a lot of eucalypts when I lived in Australia, and then when I went down to San Diego in California a few years ago, I was astonished about how many eucalyptus trees were in San Diego. But not only that, not only they were so abundant, but they were enormous. They were about twice the size of any eucalypt tree I'd seen in Australia ever. And the reason is, Australian soils are very nutrient poor. So when these trees were introduced to California, they grew incredibly well because the soil was so nutrient rich. Now these eucalypts in California, just as they do in Australia, they survive fire very well. And what this means is that high fuel loads are present soon after a fire, decreasing fire intervals. These eucalypts burn incredibly well, but they also recover after a fire very, very well indeed. What this means is, although the fire has ripped through the area, the eucalypts, and therefore potentially the fuel, is still present. So after the post-recovery, you can have another fire very, very quickly. So it's pretty crazy. And together, invasive cheatgrass and eucalypts have increased the probability and severity of fires. Now these data are a little bit out of date. It goes up to 2008, 2009, 2010, 2011. What it's showing is this is across all the ecoregions of the West and Midwestern United States. And this shows how the fires have changed. So these graphs are the fires have changed. So across all ecoregions, they've increased. We can look at the ecoregions that include us, that's the Basin and Range, they weren't very high anyway. Snake Plain and Columbia Plateau, yep, that's increased. The Sierra, Klamath, Cascade Mountains, this area in the north, that's gone up a lot. Mediterranean California, and this graph had actually stayed very similar because Mediterranean California is the sort of southern bit where a lot of people live, so as a result they specifically try and put out the fires. But you can see that in the Cascade Mountains, this area on the far side of the Central Valley, it's gone up a lot. The Rocky Mountains, the green, gone up a lot. Northern Plains, the blue, gone up a lot. Southern Plains, this sort of light green, gone up a lot. Arizona and New Mexico mountains, gone up an awful lot. And the warm deserts of the south, also gone up a lot. So right the way across all of this area, you've seen a big increase in the probability of fires, the number of fires, and the severity of fires. So let's have a think about the consequence of wildfire. Well, one of the big ones that makes the news a lot is loss of human life. So in 2018, 88 people died in wildfires in California. In Australia, 27 have died this fire season already. And in many cases, these deaths were what we call defenders. So defenders are people who, when they're ordered to evacuate because there's a fire coming, instead they stay and try to fight the fire themselves to keep it from damaging their property. And many of those people actually end up dying because there's no way you can fight it. So this is a really headline-grabbing statistic, and it's a very easy thing to measure, the direct number of people just dying because of wildfires. In addition, it's brutal to imagine, but we can imagine in our heads what it must be like to be caught in a wildfire. And it's just a sensation that none of us really want it to happen. It's not only is it it's a terrible, terrible outcome. But so as a result, it's very evocative. And we can think about it. It's easy to measure. It makes good headlines. But what's often a bigger long-term problem is the consequences for human health. Because smoke inhalation can affect the respiratory system. Smoke inhalation is associated with bronchitis, asthma, and increased emergency room admissions. It has led in many cases to many premature deaths. We can actually measure this in the hospital. One of the ones that really drew attention last year was the tennis player Dalia Jukic, who collapsed and had to retire from a match in the Australian Open, even though she was leading it, because the smoke from the wildfires was so bad during the Australian Tennis Open, she couldn't breathe and was unable to continue and ended up in hospital. So think about it. This tennis player, she was not somebody who is old and sick and immunocompromised. She was a world-class athlete. She's one of the fittest people on the planet, but she ended up hospitalized because she was playing tennis and breathing heavily and breathing in smoke from Australian wildfires during a tennis match. We can actually measure in the US the relative risk of being hospitalized based on smoke density. So on this graph we've got, these are all-cause cardiovascular hospitalizations. These are all-cause cerebrovascular hospitalizations. So cerebrovascular is things like strokes and blood and the brain. And this is all-cause respiratory. So what we can see, and then we've got light smoke, medium smoke, dense smoke, and we've got three categories. The red is adults aged 45 to 64. The blue is adults 65 plus, and the green is all adults 19 and up. And what we can see is, so we look at all-cause cardiovascular, so this is lungs and heart. As you increase the smoke from light to dense, both the 45 to 64, so the adults over 65 and all adults 19 plus, you get an increased risk of being hospitalized compared to the baseline. You also get an increased association with smoke, with strokes, and all your respiratory, you get an increase as well. So we can actually measure this in terms of hospitalizations. One of the other consequences of wildfire is cost. So the cost of dealing with wildfires has increased dramatically. Now this cost is just based on fire suppression. The cost I'm talking about here does not include compensation post-wildfire or evacuation costs. So we can see here on the x-axis we've got year. The y-axis we've got cost in billions of dollars, US. We can see since 1985 we've had a dramatic increase from about $500 million spent on fire suppression up to $3 million spent on fire suppression. Now these are predominantly tax dollars. So the interesting thing about the wildfires is the Forest Service is responsible for firefighting. When we talk about suppression, that does include putting out fires. And these costs are paid by the Forest Service. So if a fire breaks out on, for example, Utah state land, it's the Forest Service that is, even though the land belongs to the state, it's a federal agency that comes and helps put the wildfire out. Now, what's critical about that is that means that the money is coming from the federal government, and also this is one of the reasons why people are often unhappy that the Forest Service is always runs a huge deficit. So the Forest Service is always asking for more money because it's running out. And everyone's like, well, why is the Forest Service not able to sort out its revenue a bit better? And the reason is because the Forest Service is responsible for putting out all the wildfires. So as a result, we get a big increase. And we see this big increase, and it's paid by a federal agency. In addition to the cost, we also have property damage, because property damage is not included in firefighting costs. So the recent damages from the big outbreaks in California and Australia have not yet been calculated. So we have to go back a bit further. So in 2017, the fires in California alone caused $18 billion in property damage. Of this, $13.2 billion was insured, which means $4.8 billion was not insured, and that the bill had to get paid basically by the public. So you compare this value to the $3 billion spent on fire suppression nationally. And so we can have situations like this, where this is a town that's been affected by fire. You can see how far the fire got with the burnt houses compared to the ones that are still standing. So each one of these, they will have had homeowners insurance with any luck. Even then, it's still going to cost them money. If they didn't have homeowners insurance, they now own a flat pad rather than a house. So it's a big deal. In addition, we have ecosystem impacts. So many trees can survive if the fire doesn't reach the canopy, the higher section. But fires do destroy understory plants. And some animals can move away and escape the fire, but even if animals move away, they may be unable to find food. And this was a major problem in Australia because of the extent of the fires. So although many fast-moving species like these kangaroos were not impacted by the fire directly, they were able to escape the fire, they then started to starve to death because there wasn't enough forage left on the landscape. So it's a big deal. We can also get ecosystem impacts on a broader scale because wildfires emit CO2. And about 20% of global CO2 emissions associated with people are from wildfire. This amount is predicted to increase to 30% by 2100. And this actually means the relationship between wildfire and CO2 could become a positive feedback, because wildfire releases CO2 into the atmosphere. More CO2 in the atmosphere then causes increased temperature, which changes the fuel load, and it changes the moisture index. It changes the amount of the length of the fire season. So this increased CO2 then increases the burn severity and the chance of wildfire. More wildfires release more CO2. More CO2 increases the chance of wildfires, and on and on and on. And this is what we call a positive feedback. So it could be problematic. In terms of wildlife loss, it's currently estimated that over 1 billion individual animals have died in Australia in the last year due to wildfire. So many of these were killed directly by the fires, but others have subsequently perished due to habitat loss. Some of the most startling of these is things like 30% of the koalas in New South Wales, which is the state that contains Sydney, are gone. They were killed in the last bout of wildfires. So it's a big impact. Okay, so now I'll just do another clicker question. So what best describes the wildfire situation in the USA? Is it A, most fires start naturally? B, climate change has not increased fire, but more people are starting fires? C, climate change has increased the intensity of fires, most fires are started by people? D, climate change is causing more people to live in fire-prone areas? Just give you 10 seconds on this. Okay, well, the correct answer is C. Climate change has increased the intensity of fires. Most fires, however, are still started by people. Okay, so let's now look at recovery after a fire. Well, many species can actually survive. The individual itself can survive if the intensity is low enough. This here is an image of an Australian forest after a wildfire, and you can see there's an awful lot of green in there, especially these ferns. Palms, sorry, ferns. But in other cases, if the individual itself can't survive, there might be buried seeds in the soil and they can survive. So even if the adult trees and plants are burned away, the seeds in the soil can regenerate and regrow. And rapid regrowth of forests and natural areas is observed after a fire. And fire can reduce competitive dominance, it can reduce species that take over and outcompete others. So remember, the intermediate disturbance hypothesis is based on this. But if fires are part of the landscape, why are they so bad now? Well, we have to think about the concepts of resilience and an ecological threshold. So this figure is just as old as the first ecological textbook, I think. And what it is that the red ball represents the state of an ecological system. Okay, so this ecological system, it's a ball, so it always rolls to the bottom of a valley. And if you move the system, the ecological system, up or down a little bit, if you disturb it and move it around, well, because it's going downhill, the ball will just roll back downhill and it'll go back down to its normal, happy state of the system. And this amount that it can roll back is called the resilience. So how far away you can push it and it just rolls back, that's how resilient a system is. However, if you disturb it so much that you push it over this threshold, well, now the little ball will not return back down into its original state. It'll actually roll down this side and go into a new state, a new system state. And the issue with this new system state is it takes an awful lot of effort to push it back over the threshold and get it back to its original state. So it can, if you move it a little bit, it'll just return back to its original state. If you push it too far, it'll fall down and it goes into a new system state. Okay? And the increased number and intensity of fires may push an ecosystem over a threshold into a new state. So this system represents our a sort of ancestral state. So we've got a low landscape flammability. The landscape isn't very likely to burn. As a result, we get lower severity fires. Because we've got lower severity fires, we have forest species dominate, and these forests shade out shrubs. And so because the forests are shading out the shrubs, we're in a we have low landscape flammability. Because we've got low landscape flammability, low fires. And the system is in this state, and it moves around in a stable state. However, if we put a fire threshold and we push the system over this fire threshold, we can change it to a new system with a highly flammable landscape. So in this landscape, we've got a highly flammable landscape. That leads to increased fire severity. Increased fire severity, this fire kills off the young trees. As a result, flammable shrubs, these smaller shrubs, dominate. Because we've got flammable shrubs, we now have a highly flammable landscape, and we're now stuck in this state. Okay? So just by having a low flammability landscape, but by increasing the number of fires just a little bit so that it pushes it over this threshold, we can change the entire landscape from a low flammability to a high flammability, and this is now a stable state. It's very difficult to remove. And these new stable states may exclude some species. So for example, in Australia, koalas are gum tree specialists. They love a gum tree, they love a eucalypt. Now these gum trees generally survive fires very well, but excessive fires can actually cause the conversion to other ecosystem types, and this in many places has led to the extirpation of koalas. So I have to admit, like overall, this picture appears pretty bleak, and I have to apologise for that. But we have to remember, fires, well, they are a natural feature of many, but not all, ecosystems. But global changes have caused fire regimes and caused new areas to burn. Invasive species in some places have increased the fuel load, and all of this has increased the impact of fire well above natural levels. And I just had to include this meme here because this is just such an unfortunate picture. So this is during some of the floods that followed a hurricane. In the middle of a gigantic flood, this poor schmo's house has gone ablaze. And so someone put this picture up as proof that no matter what's going on, things can always get worse. Okay, so just another quick clicker question. So how do fires lead to alternative stable states? Is it A, lots of fires remove trees and allow shrubs to grow. These shrubs lead to more fires, meaning trees can't recover. B, fires burn plants and animals, leaving them in a terrible state. C, cattle graze all the grass, reducing the chance of fire and preventing forests growing. D, fires present CO2 going into the atmosphere, changing the state of the world. Just give you 10 seconds on this. Okay, well in this case the correct answer is A, lots more fires remove trees and they allow shrubs to grow. These shrubs lead to more trees, meaning more fires, meaning trees can't recover. Okay, so the situation does look pretty bleak, but what can we do? Well, first up, remember, about 85% of wildfires in the US are human caused. So we can't immediately change the climate back. We can do it slowly, we can't do it immediately, but we can reduce ignition. And the major thing, to be honest, is always extinguish campfires when you leave or when you sleep. I know how tempting it is when you're going to bed, when you're camping and you're going to bed, how tempting it is just to leave the fire burning so that it's still just smouldering in the morning, and it means that in the morning you don't need to relight the fire, you just throw a couple of logs on and the thing goes up again. It's so tempting, but sleeping next to a lit campfire is not only dangerous directly for you, but it can spark these large wildfires. The other thing you've got to do, generally, don't be an idiot. Like, I wanted to show you this video because it hits on two things that I always talk about in this talk. So let's stop sharing this. Hello. And share a different window. Where is it at? Here it is. Share. No, thank you. Let's go this. So this is, let's see if we can make this go. This is critical. Off-duty border patrol agents.
Start packing up! Huh? Start packing up! Yep.
So, yes, a border patrol agent had a gender reveal party and caused $8 million worth of damage by igniting a wildfire. It said in there he was going to pay monthly installments to pay restitution. I can't imagine how long it's going to take a border patrol agent to pay off $8 million in restitution. It's pretty staggering. Right, let's go back to the PowerPoint and just get finished up. Okay. So, yeah, put out your campfires, don't be an idiot, two of the important ones. And what can we do? Well, more generally, increased wildfires are a symptom of global change. Generally, it's only through long-term societal change that we can increase the moisture index, and also some changes to land use and invasive species may actually be irreversible. So the one thing we can do on a global scale is, reduce our CO2. So that's the end of this lecture. You guys should now be able to describe the causes and consequences of wildfire, compare and contrast the future of wildfire. Okay, that's as far as I wanted to get to today. I shall see you next time.